I remember the first time I saw the solar system. It was flat, clean, orderly, a glowing yellow sun in the center. Perfectly spaced planets lined up like beads on a string. Mercury, Venus, Earth, Mars. It looked manageable. I didn't feel small looking at it. I felt confident, like space was something we could cross if we just tried hard enough. That image lied to me, and if you've ever seen it, it lied to you, too. Because space is not arranged like that. It never was. If I asked you right now how far Mars is from Earth, you might give me a number. Millions of kilometers. Maybe tens of millions. You've heard it before, but that number doesn't scare you. What should scare you is how long it takes to cross that distance. Because space isn't measured in kilometers, it's measured in waiting. And once you understand that everything you thought you knew about space travel begins to fall apart, those beautiful diagrams we grew up with did one thing very well. They made space feel reachable, planets neatly spaced, orbits drawn as perfect circles, everything labeled, everything tidy. It feels like a neighborhood, like cosmic real estate. But none of those diagrams are drawn to scale. They can't be. If they were, Earth would be smaller than a grain of dust. The moon would be several meters away, and the next planet would be so far off the page you wouldn't even know where to look. The truth is brutal. Between planets, there is mostly nothing. Not emptiness the way we imagine it, but distance so vast it erases intuition. Why space maps? When I look at a subway map, every stop feels close, but that doesn't mean I can walk it. Space maps do the same thing. They collapse billions of kilometers into something your brain can tolerate. They make the impossible feel familiar, and familiarity is dangerous. The moon feels close. We've been there. We've walked on it. We've planted flags and left footprints. It feels like a weekend destination, but the moon is nearly 384,000 kilometers away. That's 10 times the circumference of Earth. And even at rocket speeds, it takes 3 full days to get there. 3 days to reach something that feels like it's hanging right. We think distance is the enemy. It's not. Speed is. On Earth, distance feels conquerable because speed is abundant. Cars, planes, trains. But in space, speed is rare. Our fastest machines crawl through the void like insects. Trapped in amber, even the fastest human-made objects move at a pace that would embarrass light itself. And light, even light, isn't fast enough. I realized something unsettling when I first heard this. Voyager 1 has been traveling since 1977, more than 4 decades. It has left the solar system, and it still hasn't traveled one full light-year. Space isn't a place, it's a schedule. Every destination comes with a time, cost so large it reshapes lives. Mars isn't far, it's 6 months away. Jupiter isn't distant, it's years. Saturn isn't remote, it's a career-long commitment. And the stars, they're generational. You don't visit them, you dedicate civilizations to them. Think about that. Not miles, not kilometers, but birthdays missed, children born, careers ended, all while a machine drifts silently through darkness. That's the cost of space. Travel, not fuel, time. Movies made space fast. Ships jump, engines roar. Planets blur past windows, but reality doesn't cut scenes. Reality waits. Reality stretches seconds into years. Reality doesn't care about urgency. The the true CLA space were reduced so that Earth was the size of a marble, the nearest star would be thousands of kilometers away. No roads, no shortcuts, no refueling stations, just darkness, and waiting. So when we ask, how long does it take to reach each planet? We're not asking about rockets. We're asking about patience. We're asking about endurance. We're asking how long humanity is willing to wait just to arrive. And if the closest worlds already demand years of our lives, what does that say about the ones waiting farther out? If space isn't measured in distance, but in time we can never get back, how far are we really willing to go before we talk about planets, before we talk about years, before we talk about journeys that stretch across lifetimes? We have to talk about leaving, because no matter how powerful our dreams are, no matter how advanced our machines become, every journey into space begins with the same silent enemy, gravity. It doesn't announce itself. It doesn't threaten you. It simply holds on, and it never lets go willingly. If you stand on Earth right now and look up at the sky, it feels open, inviting, limitless. But that feeling is a lie, because Earth is not a launch pad. It's a prison with invisible walls, and to escape it, you don't need to go up. You need to go fast, faster than anything humans were ever meant to move. Most people imagine space travel like this. A rocket lifts off. It climbs higher and higher. Eventually, it reaches space, and then it just keeps going. But that's not how Earth works. Earth doesn't care how high you go. You can climb hundreds of kilometers above the surface, float in the darkness, watch the curve of the planet glow beneath Ewand, still be trapped, because gravity doesn't end. It fades, and fading isn't freedom. Why? Height doesn't matter. The International Space Station orbits Earth at about 400 kilometers above the surface. That sounds high. It's higher than any mountain, higher than any airplane, higher than the atmosphere itself. And yet the astronauts aboard the ISS are still deeply inside Earth's gravitational grip. In fact, gravity up there is about 90% as strong as it is down here. They aren't floating because gravity is gone. They're floating because they're falling constantly. This is one of the strangest truths about space. Orbit isn't balance. It isn't suspension. Orbit is a controlled fall. The spacecraft is moving sideways so fast that as it falls toward Earth, the planet curves away beneath it. It misses the ground forever. That's orbit, not escape. To actually leave Earth, to break free from its grip entirely, you must cross an invisible boundary, not in space, in speed. It's called escape velocity. And it doesn't care how big your rocket is. It doesn't care how powerful your engines feel. It only cares about one number, 11 kilometers per second. That's about 40,000 kilometers per hour. Let me slow this down. A commercial airplane cruises at about 900 kilometers per hour. A fighter jet, just over 2,000 kilometers per hour. A rifle bullet leaves the barrel at roughly 1 kilometer per second. To escape Earth, you need to move more than 10 times faster than a bullet continuously, while carrying fuel, while climbing through thick air, while fighting gravity, every second of the way. Why escape is so hard. Here's the cruel loop. The more fuel you carry, the heavier you are. The heavier you are, the more fuel you need, which makes you heavier, which means you need even more fuel. This is why rockets look the way they do. Tall, loud, mostly fuel, about 90% of a rocket's mass. At launch is fuel. The actual spacecraft, the part with people, instruments, dreams, is tiny. Everything else exists just to throw it fast enough to leave. When a rocket launches, it's not flying, it's surviving. Temperatures reach thousands of degrees. Vibrations rattle the structure apart. The forces press astronauts into their seats, like gravity itself is trying to crush them back into the planet. All of that just to reach orbit, not even freedom. Why rockets don't go straight up? Another illusion. Rockets don't shoot straight into space like darts. They tilt, they curve, they chase sideways speed, because vertical height is useless without horizontal velocity. The goal isn't to climb. The goal is to outrun Earth. Reaching orbit takes about 7.8 kilometers per second. Escaping Earth entirely takes 11.2 kilometers per second. That difference doesn't sound big, but in spaceflight terms, it's enormous. It's the difference between circling home and never coming back. Apollo, just barely Ifari. When Apollo astronauts left Earth for the moon, they didn't blaze through space at impossible speeds. They crept past the threshold. Their spacecraft reached about 39,000 kilometers per hour. Just enough. Barely. Earth loosened its grip, not because it wanted to, but because it had no choice. There's a moment in every space mission that no one talks about. The engines cut off, not because the journey is over, but because the fuel is gone. From that moment on, the spacecraft is coasting. No thrust, no correction, just momentum, just time. Once you escape Earth, you don't keep accelerating, you drift. You become a passenger of physics. That's when the scale of the universe finally begins to press in. The fastest human-made object ever built is the Parker Solar Probe. At its peak, it reaches about 700,000 kilometers per hour. That sounds absurd. It could circle Earth in under a minute, and yet at that speed, reaching the nearest star would still take over 6,000 years. This is when it becomes clear Earth is not easy to leave, not because we lack intelligence, not because we lack ambition, but because the universe is built to keep us where we started. If something goes wrong during launch, there is no retry, no pause, no second chance. Every rocket launch is a single roll of the dice. Years of planning, billions of dollars, lives on top of controlled fire. All decided in minutes. So why do we do it? Why fight gravity at all? Because Earth is safe, and safety is suffocating. Because everything we've ever learned came from stepping beyond what held us down. Escaping Earth is the hardest part of any space journey. Not Mars, not Jupiter, not Saturn, Earth. Every mission that failed here. Every success paid the price here. Leaving Earth isn't just physics, it's emotional. It's the moment when the planet shrinks beneath you, when oceans become colors, when continents lose names, when home becomes fragile. Once you cross escape velocity, there is no falling back, no drifting down, no rescue. You are committed to the clock, because if escaping Earth alone costs this much, if breaking free takes fire, precision, and sacrificed in reaching other planets, won't just test our technology, it will test our patience. Earth was the first lock, the easiest one. The planets ahead are guarded by something far worse than gravity, momentum, timing, endless waiting. If escaping Earth already pushes us to the edge of what we can survive, what happens when the real journey begins? If space travel were fair, Mercury would be easy. It's right there, closer to the sun than any other planet. Sometimes visible with the naked eye, glowing low on the horizon just before sunrise or after sunset. It feels like the first step outward, like the universe offering us something simple before the real challenges begin. But space is never fair, and Mercury is proof that closeness means nothing. Mercury is the closest planet to Earth on average, and yet it's one of the hardest places we have ever tried to reach. Not because it's far, but because it's falling endlessly toward the sun, and to meet it there, we have to do something that feels completely wrong. We have to slow down on Earth. Getting somewhere closer means using less energy, a shorter drive, a shorter flight, less fuel. Our instincts tell us the same should be true in space. Mercury is inward, closer to the sun, so it should be easier than Mars, right? That assumption has ruined missions before they even began, because space doesn't reward shortcuts, it punishes them. The moment you leave Earth, you don't stop moving sideways. Earth is orbiting the sun at nearly 30 kilometers per second. That sideways motion doesn't disappear when you launch. You carry it with you. Every spacecraft leaving Earth inherits that speed. That means the moment you leave, you are already racing around the sun to reach Mercury. You must lose speed, not gain it. You have to cancel a huge portion of that sideways motion. That's like trying to jump off a speeding carousel and land gently near the center. There are no brakes in space, only momentum. Mercury orbits the sun at nearly 47 kilometers per second. That's faster than any other planet. The closer you get to the sun, the faster everything moves. So while Mercury is closer, it's also running away sideways at terrifying speed. To catch it, you must match that motion perfectly. Too fast, you overshoot. Too slow, you miss entirely. Why rockets can't just be RAK on Earth. Slowing down is easy. You press a pedal, friction does the rest in space. Slowing down means firing engines for minutes, sometimes hours, burning fuel you don't have. That's why Mercury missions are nightmares of planning. The first ATMPT, 1973. NASA tried anyway. They launched Mariner 10, humanity's first attempt to visit Mercury, and immediately realized something terrifying. A direct path wouldn't work. They would fly past Mercury too fast to stop, so they took a detour. Mariner 10 flew past Venus first, not by accident. It stole energy from Venus, a gravity assist, a planetary sleight of hand, using another world's motion to slow itself down. Only then could it fall closer to the sun. Even with that trick, Mariner 10 couldn't stay. It flew past Mercury 3 times, each time snapping photos, each time fleeing again. It never entered orbit. It didn't have enough fuel to slow down further. Mercury revealed itself only in glimpses, a scorched, cratered world, half lit, half unknown. Decades later, we tried again. In 2004, NASA launched Messenger, better computers, better navigation. Same physics. Messenger didn't arrive until 2011, 7 years to reach a planet closer than Mars. 7 years spent shedding speed, the speed of light, COMPR, isonet, light speed. Mercury is 4 minutes away. 4 minutes at our fastest spacecraft speeds. Years. The difference between what is theoretically possible and what is humanly achievable. The humiliation of Mercury humiliates us. It's small, silent, close, yet it demands decades of technology and patience. It exposes how primitive we still are. The psychological shift. This is where space travel stops being exciting and starts being humbling. If the nearest planet inward takes 7 years, what chance do we have farther out? The uncomfortable light. Why Mercury isn't a stepping stone, it's a warning. It tells us that the universe doesn't reward ambition, it rewards discipline. If Mercury teaches us how hard it is to slow down, the next planet teaches us how fast we can fall. Because Venus is close, closer than Mercury ever feels, and reaching it is shockingly fast. Too fast if the closest planet inward takes years of patience and perfect timing. What happens when a world is close enough to reach quickly, but deadly enough to regret it?